Next we will see the different types of transmission line. First, lossless transmission line. So as the name suggests, lossless means the loss should be 0. So the condition for a lossless transmission line is R should be equal to 0 and G should be equal to 0. That means if there should be no loss, then there should be no voltage drop. If there should be no voltage drop, then the resistance should be equal to 0. Similarly, if there should be no current leakage, then the conductance should be equal to 0. So that is how we arrived at the condition R equal to 0 and G equal to 0. These are the two conditions of a lossless transmission line. Now, gamma is equal to alpha plus j beta, that I am going, which is equal to square root of R plus j omega L into G plus j omega C. I am going to substitute R equal to 0, G equal to 0 in this expression. Finally, I will get as gamma is equal to j omega into square root of LC. Next, what I am going to do is I am going to equate this j omega square root of LC with alpha plus j beta. So you can see in j omega square root of LC there is no real term. So alpha is equal to 0 and beta is equal to omega LC. Where beta is your phase constant and alpha is your attenuation constant. Similarly, coming to the characteristic impedance Z0, we have the expression which we derived earlier as R, the square root of R plus j omega L by G plus j omega C. I am substituting the condition R equal to 0, G equal to 0. Finally, I will get Z0 is equal to square root of L by C. Earlier, we saw the expression for beta as beta equals omega square root of LC, and we have the expression for beta in terms of lambda as 2 pi by lambda, and instead of omega 2 pi f, then square root of LC. Okay, 2 pi cancel. Then I am slightly rearranging the expressions on both sides, and finally I am getting as f lambda is equal to 1 by square root of LC. And you know f lambda is equal to c, right, which is your phase velocity, which is often represented as Vp. So instead of Vp I can use a term, instead of f lambda I can use a term Vp, that is equal to 1 by square root of LC. So this is the phase velocity of a lossless transmission line. Next, we will see the distortion transmission line. So transmission line in which the attenuation alpha is independent of frequency and phase constant beta is linearly dependent on frequency is known as distortionless transmission line. And the condition for distortionless transmission line is R by L is equal to G by C. Now coming back to gamma, we have it is equal to square root of R plus j omega L into G plus j omega C. And from the first term I am taking R outside, and from the second term G. So finally I will get R into 1 plus j omega L by R into G into 1 plus j omega C by G. So here we have the condition R by L is equal to G by C. So here you are having the term L by R, that you can write it as what? C by G. So R into 1 plus j omega C by G into G into 1 plus j omega C by G. So finally I can write R is equal to square root of Rg into 1 plus j omega C by G the whole square, which is equal to alpha plus G beta. So I am removing the square root and then I am opening the bracket. So finally I will get gamma is equal to alpha plus j beta is equal to square root of Rg plus j omega C square root of Rg by G. From that I will get alpha is equal to square root of Rg and beta is equal to omega square root of Rg into C by G. This equation, if you want, you can simplify further. Okay, this formula you can simplify further. Again, coming back to characteristic impedance, you know the expression is square root of r plus j omega L by g plus j omega c. I am taking r outside, g outside, arranging the terms. Finally, I will get the square root of r by g, which is your z0. Similarly, you will get the expression for z0 as square root of L by c also. The derivation is given here. Okay, you can go through. So finally, I can conclude that z0 is equal to square root of r by g, which is equal to square root of L by c. Next, we will see wave velocity. Wave velocity v is given by the formula omega by beta. Beta, you know, here it is given as what? Beta is equal to omega square root of rgc by g. That you can substitute here. Simply rearrange the terms. Finally, you will get v is equal to 1 by square root of root Lc, which is equal to u. Here u is, why I have written u is, sometimes this alphabet is used to represent phase velocity. That is why I have written u there. So phase velocity v is equal to 1 by square root of Lc, which is equal to u, which is known as your which is the phase velocity of the wave velocity of electromagnetic wave in a transmission line. And that's all. Thank you.